Hi, Trigoners. So today we're going to talk about chapter 1.1, and our notes are going to be on linear equations and applications. So the first thing I want you to do is look at A and B and decide what is the difference between these two problems. Are they the same? Are they different? Go ahead and pause the video and think about what would be different about them. All right, so hopefully you realize that the first one was an equation. It has an equal sign, and we solve equations. And the second was an expression, and we simplify expressions. So go ahead and pause the video again and see if you can solve for A and simplify for part B. Okay, so when you solve, you can multiply both sides of the equation by the same number. But when you simplify, you don't have an equation. So you can't multiply, you'd be changing the value. So what you would have to do is get a common denominator. So let's look at part B first, where I got a common denominator for all three terms. Remember, terms are separated by a plus or minus sign. So the common denominator was 6. And so I went ahead and added 3x plus 2x is 5x, and we have 5x plus 60 over 6. But for the equation, I could multiply both sides of the equation by 6. So you would end up with 3x plus 2x equals 60. And we solve. Okay, so what I would like to do next is practice a little bit more with solving. So if you take a look at number 1, it'd be nice if we didn't have all these fractions. So decide what you're going to multiply every term by, both sides of the equation. All right, did you decide to multiply every term by 15? If you do that, you won't have fractions because 15 divided by 5 is 3. 15 divided by 3 is 5. And the 15 cancel out. Okay, so go ahead and simplify and see if you can come up with an answer. Pause the video and then come back when you're done. Okay, so in this step I distributed the 5, and now I can combine like terms. I have 18x minus 10. So now I want to isolate the x's on one side of the equation, so I can subtract 6x and add 10 to both sides, and you end up with 14 over 12, which is the same thing as 7/6. For number 2, you would solve that one a little differently because the first thing you have to do is factor. So go ahead and factor the denominator for the first term. Pause the video and come back when you're done, please. Okay, so now that you've factored the denominator, you can see that if you would like to eliminate the fractions, or sorry, eliminate the terms in the denominators, you could multiply by the quantity a plus 5 and the quantity a minus 3. So go ahead and multiply every term by a plus 5 and the quantity a minus 3 and see if that simplifies things for you. Pause the video and come back after you've finished. Okay, so did you cancel the a plus 5 and the a minus 3 in the first term? You're just left with 2. And in the second term, the a minus 3's cancel. And in the term on the right, the a plus 5's cancel. So if I distribute the negative 3 and the 3, now I can isolate the a's. Go ahead and add 3a to both sides of the equation and add 9. Pause the video and turn it back on to check your answer when you're through. Okay, hopefully you have an answer of negative 2/3 because we added 3a to both sides of the equation. And we can do 2 minus 15, which is negative 13, and then add 9 and get negative 4, and then you divide. Let's go ahead and go to the next section. We're going to talk about literal equations. Now, these are called literal equations because we have other letters in there. So what we're going to do is we are going to solve for the indicated variable. So we are going to solve for x. So let's go ahead and think about how are we going to collect all of the x's to one side of the equation. You could subtract bx from both sides of the equation. But now you would like to isolate the x. So think about how could you factor out an x from both of these terms. So go ahead and pause the video and try and factor an x from on the left. Try and factor an x, a common term, on the left side of the equation. Nice job, everybody. So did you factor the x and realize that you had 5a minus b in parentheses, and then you could divide d minus 10c by 5a minus b. Okay, let's take a look at the next one. This time I decided to solve for a. So that means at the very end you're going to have a on the left side of the equation all by itself, and you're going to have other letters on the right-hand side, anything except a. So you might want to, first of all, try and have the ab bring that to the numerator. So let's multiply both sides of the equation by AB. So on the left side of the equation we have ABX, and on the right side of the equation we have A plus B plus C. So that looks better already. Now think about how could you isolate the A to one side of the equation. Go ahead and pause the video and try that. Okay, so did you realize you had to subtract A from both sides of the equation? And if you do that, notice that you have A's on the left-hand side, and you could factor out an A. So your last step is to go ahead and divide both sides of the equation by bx plus 1. So we isolated the A. Okay, the next problem is a word problem. It says find 3 consecutive odd integers so that the sum of the first two is 9 more than the third. So the first thing I want you to do is think about how you could describe odd integers that are consecutive. So if x is the first number, how would you describe the next two? Because it says find 3 consecutive odd integers. So go ahead and pause the video and try and figure out how you would describe the next 2 consecutive odd integers using x. Let's look over here on the right hand side. So notice that consecutive odd integers means 1, 3, 5, 7, 9, for example. So you would add 2 to get the next odd integer if they were indeed if they were consecutive, you would have to add 2. So notice we can say that we have x plus 2 because it says the sum of the first two, so add those together, is, so equal signs, 9 more than the third. So take the third and add 9. Go ahead and solve that equation and see if you could figure out what those 3 consecutive odd integers would be. Okay, so hopefully you end up with 11. So that means that this first one is 11, the second odd integer is 13, and the third odd integer is 15. Nice job, everybody. We have one more thing to cover today. We're going to go ahead and talk about mixture problems. So I want you to go ahead and read number 1 and just think about what we'll be doing, and then we'll think about the basics in just a minute. So go ahead and pause the video and read number 1. So let's think about what they're asking. They want us to add a 45% solution to a 75% solution and end up with a 50% solution. So first of all, let's think about if that's even possible. If you added a stronger solution to 45%, could you make it 50%? I think you would realize that you could. So you probably don't want that many gallons of the 75 compared to the X gallons of 45%, because really if you're at 45%, you're almost at 50%. So again, if I had to guess right now, I would probably think I need quite a bit more of the 45% solution. So let's think about what we've got. If you have X gallons in the first beaker and 4 gallons in the second beaker, and you're going to pour them together into the last beaker, doesn't that mean that you have X plus 4 gallons? So that's actually good to know. So we're going to figure out how much acid. So I want to know alcohol. How much alcohol is in the first beaker? Wouldn't 45% of those X gallons be alcohol? And the other 55% must be something else, like water perhaps? And in the second beaker, I want to know how much alcohol is in that beaker. Well, isn't 75% of those 4 gallons alcohol? And then 50% of the X plus 4 gallons are alcohol. So go ahead and pause the video and practice solving equations. All right, let's see if you were able to solve this one. So we had our equation. You're going to distribute your 0.5 to X and 4. So notice when you go ahead and isolate the X, you can subtract 0.5X from both sides of the equation. So you have negative 0.05X equals negative 1. If you divide negative 1 by 0.05, you end up with 20 gallons. So that makes sense. We were expecting a lot more than the 4 gallons of 75% to end up with a 50% solution. Okay, let's do another one. Go ahead and read number 2 and see if you can set that one up and end up with an equation. Go ahead and pause the video and then come back when you're done. Let's check your equation. So if you have distilled water, you have 0% alcohol. So 0 times X plus you have a 40% solution, and there are 50 liters. So 40% of those 50 liters are alcohol. And then you're going to end up with, if we have X liters and 50 liters in our result, we have X plus 50 liters. So we have 30% of that as alcohol. So we have an equation that has the alcohol, the pure alcohol from the first beaker, plus the pure alcohol from the second beaker, and that equals the pure alcohol from the third beaker, which is a true statement. So go ahead and multiply 0.4 times 5 and distribute your 0.3 and find out how many liters are needed. All right, so hopefully you went ahead and multiplied 0.4 times 5 and had 20, distributed your 0.3. If I subtract 0.3, subtract 15, I end up with 5 equals 0.3x, and now you divide. 5 divided by 0.3 is approximately 16.67 liters of distilled water. So we're going to stop the video right now. We're going to do the last example in class. Have a great day, everybody.